The whole idea of this entire unit is this right here. How do you find the slope of a point? Okay? How can you find the slope of anything unless you have 2 points? You need 2 points. Okay? You need, change in y over change in x. I'm sorry, people at home. You're doing change in y up top. That's just y1 minus y2 over change in x on the bottom. So how can you do that if you have 1 point? What's cool about this is you say the 1 point is the only thing you're looking at, and you plug it in for both of them, you end up with a 0 over 0. I mean, think about it. Let's just say the point was, let's just say this was 1, 1. It would be 1 minus 1 over 1 minus 1. Or if you did like 1, 2, it'd be 2 minus 2 over 1 minus 1. 0 over 0. So that means you should be able to use limits to find that impossible problem. And if you remember what I was talking about with the first unit, I said limits let you find impossible things, impossible in quotes, such as finding the slope at 1 point. So unit 2 is all about differentiation. If you hear that word, that just means the process of finding the derivative. Okay, derivative, differentiation, differentiate, all that stuff means find the derivative. Okay? That's the process of finding the derivative. I could have called this unit derivatives if I wanted. It would have been the same thing. In 2 units, we're going to be on anti-differentiation, which is anti-derivatives, which is also known as improper integrals. We're going to go over that later as well, but we're going to go backwards. So this one is forwards with derivatives. Eventually, we're going to be going backwards with derivatives as well. So the way I engineered this class is like everything builds very nicely. Here are the essential questions. I'm not going to read over these right now, but you should be able to answer all of those questions by the end. Okay? So if I said, number 1, how is the slope of a tangent line calculated? You should be able to find that. You should be able to tell me how to do that. Slope of a tangent line is the same thing as the slope of a point, so that's the derivative, essentially. How is differentiability defined? Differentiability means the derivative exists. Just like limits don't exist, well, derivatives are based off of limits. Where am I at here? Whatever, I'll just go over it later. But derivatives are based off of limits. I already talked about that. It helps you find an impossible problem. So they have to agree on both sides, and the point also has to exist. Just forget the rest of the questions. We're going to be answering these as we go, but just know these are 8 questions that you should be able to answer by the end. And if you notice, they're not example problems. They're open-ended. It's like, how would you do it? How would you find the derivative of an implicit function? I should say implicit equation. Doesn't matter. All right, here's everything in the unit except for the stuff that has double stars. Okay, double stars means Calc 2. That's why there's 2 stars on there. They are linked on the website, so if you want to get ahead in Calc 2, then by all means, you can do that. I teach Calc 2 at Waubonsie Community College, so I just throw all my stuff in one website. That way I'm not like, everything isn't just divided up. So that's why I kept that there. But you are not expected to do 232 to 234. So those last 3 sections, all Calc 2. It's more equations that you have, more formulas basically that you have to know. So the way I designed all this, 2.1 is all about just the idea of derivatives. So it just says derivatives. 2.2 is the derivative rules. It's the shortcuts. So 2.1 is like the long way of doing it, talking about limits, talking about estimating derivatives, what tangent lines are compared to secant lines. It's more like conceptual stuff. And then 2.2 is like all the formulas. And there's a lot. You might think, oh, there's just 4 of them there. There's a lot. Formulas. You'll see your mind's going to explode. It's going to be crazy. 2.3, the only section we're covering is 231. This is the hardest thing in this unit. Okay, so I advise focusing a lot of your time on implicit differentiation because it's kind of like everything all at once, and it's like kind of a weird type of equation that we're going over. That's why it says 2.3 derivatives of other forms of equations. Those are all different forms. You went over parametric and pre-calc, but the problem is by the time you take Calc 2, you're going to forget all about parametric. You did polar forms in pre-calc. You guys remember that? R sine theta, R cosine theta. But a lot of times, by the time you get to Calc 2, you're going to forget all that. So maybe look at it, but I don't really care too much. You're not going to see it on a test or a quiz anyway. All right, and this is the entire unit in a nutshell. We're not really going to go over it right now because that's just more for you later. You should be able to explain everything, and that's like your visual aid. But let's keep going. So 2.1 is all about derivatives. Secant lines and tangent lines. You know what these 2 things are. Okay? Secant line is based off 2 points, as you can see right here. There's 2 points on it. Tangent line is based off 1 point. Okay? In what was it? Geometry, you went over secant lines. So there was like a circle, and then there's usually like a tangent off the circle. Does anybody remember that? And the tangent's 90 degrees from the center of the the radius of that circle. Like it forms a 90 degree. It doesn't matter, but that's what a tangent line is. What's cool about tangent line is it's sine over cosine, which on the unit circle it's y over x. Y over x, change in y over change in x is actually slope. So it's actually related back to tangent. I think that's kind of cool that it's really just a change in y over change in x, which is just sine over cosine. Secant lines based off 2 points. You did that in algebra 1 if you were going to find the slope of the secant line. Slope of the tangent line is calc. So I'm trying to show you this picture of like the delineation between the old stuff you learn and the new stuff. Okay, differentiability just means the derivative exists. And for the derivative to exist, it has to be continuous at that point. So if you notice, I wrote the continuity. So I guess that's why we went over limits as well. You need the limit definition of continuity. That's the top one. You should know that already. The bottom one is where it's new. All this is it says the derivative at one side, the plus side, is equal to the derivative of the minus side. The derivative exists on both sides and is equal to itself. Like it's equal on both sides. Okay. Now, the top part is it has to be continuous as well. So that the derivative can match on both sides, but what if there's a hole? It also has to exist at that hole. So long story short, to be differentiable, you have to be continuous. If you are differentiable, you automatically are continuous as well, but not the other way around. You can be continuous and not differentiable. Again, we're going to go over that later. It's one of those kind of like those always, sometimes never type things. Estimating derivatives at a point, you're not actually finding the derivative. You're just using, here, it says right here. When you cannot find the derivative at a point, use points around that, okay? So essentially, it just means find the slope. So it's super easy. The practice problems on it are very basic, but I had to include it because it's on the test. So really, you're estimating them by finding the slope like the old-fashioned way, essentially. Very, very easy. It'll make sense when we do example problems. Here's where it gets crazy because of the derivative rules, okay? Here are all the formulas that you have to know. Have these memorized by the end. It's a lot. Okay, the ones that are colored in orange, that's AP. That's a delineation between AP and non-AP. So you have to do like the inverse sine stuff over here. Inverse sine. You also have to do inverse functions just generally. This is an inverse function. But every single one of these formulas you'll have to know by the end. Okay, it's gonna be crazy. You totally will be able to do it. A lot of people are like, how am I ever gonna do this? You will easily be able to do it. Okay? Otherwise you wouldn't have made it to AP Calc to begin with. It just seems like a lot because everything's a lot in the beginning. There's also ways of solving some of those out if you forget. So say you forgot the derivative of secant x, then you can actually use one of the other rules to figure it out that way too. So there's other ways around solving these. Product rule. Okay, so these are all a bunch of like individual type equations. I guess product rules in the upper right. It doesn't matter. If you are multiplying two functions and you're doing the derivative, there's a formula for that. So a function times another function. F times g, there's a formula. F over g, there's another formula. That's quotient rule. This is the number one equation that's forgotten because there's a lot to it. Okay. Then there's chain rule. This is when you do the derivative of a composite function. So if you notice f of g of x is inside f. So it's a composite function. There's a formula for it. Okay. Here's a formula for the inverse function derivative. 2.3, the last thing is implicit differentiation. Implicit equations are when you can't solve it for y equals something. So say I said y equals x squared, that's an explicit function. Well, what if you can't solve for a y? Okay, here, let me show you an example of an equation. You might be thinking, how can you not solve for a y with something? But say it was something like y cubed minus y plus 3x equals 4. You can't solve for y. You can't say y equals on that. Not very easily anyway. There's other ways around it with other math that you haven't covered. But that's an implicit equation because you can't solve for y. There is a formula for that as well. Okay, lots of formulas. More formulas here, but these are going to be for Calc 2. That's parametric. This is vectors. If you took physics, I don't think you went over vectors or did you do vectors in pre-calc? Okay, yeah, barely. This is more physics oriented, and then polar. If you remember the x and the y, well, you can do the derivative of those too with respect to theta. But we're not covering those. I just kind of wanted to show you what you have to look forward to. Also, the people that are taking Calc 2 are the people that are going to be engineers and scientists. If you're going to be a business major, because I read over all your majors yesterday in that student information form thing you filled out. I don't remember how many business majors there were, but business majors only need Calc 1, unless you're like going to some crazy college where like Harvard, they make you take a lot of calc, which I doubt they do. But business, you only need Calc 1 and you're done. It's usually called business calc. I used to teach it at Wabanzi. It's a fun class. Engineering, you have to go through Calc 4. Okay, so you should take Calc 2 if you can. Science, biology only needs Calc 1, but like physics, chemistry, you need through Calc 4. Some people are majoring in like psychology. You don't need any calculus, actually. You might have been better off taking statistics. All right, so that's everything for the overview. Again, just a brief snapshot of what's going on.